Okay guys, video number 2, since I'm limited to 13 minutes, let's see if we can do this a little bit quicker. So I was talking about keeping count. We're going to keep a global variable, so I can go ahead and print it out in the main. And since we're going to do it more than once, we want to go ahead and set it to 0. And I think that should be everything that we have to do. All right, so we should be able to, let's go ahead and test this. We should be able to call it. Let's just system. Make sure we put some comments that explain what we're doing here. So section. Right. And what do we want to return? We want to return a count, and we want to return, so let's see, bisection method. Let's return the root. And that would be bisection and A and B, and A and B. Let's create two. A equals double A equals -4 double B 5. Okay. Let's just not print line bisection method root. Okay. And then let's give it A and B. A and B. And now count. Give it a couple spaces. Count. And higher count. I'll run first in a row. We shall see. Hopefully we get something. Darn it. -1 is the right root, and the count is 0, and that's because I didn't increment the count. That would be helpful. So let's go to in our while loop and let's increment this sucker. All right, and count plus. Cool. Now let's run it. Hopefully it's on 24 or something like that. It all depends on what you set your stop amount to be. So if you have an extra 0, your mileage may vary. You may get a little bit more. So if we take out a 0, I think that's what is in the actual lab is 5 zeros. It's like 24. Yeah, that's what I expect. Okay, so -1 and 24. So obviously if you put a couple extra zeros in the stop, you're going to get closer. It's going to take you more times, but hopefully we're going to be closer to 0. Okay, so that's binary count. Let's go ahead and do the Newton method. Public static double Newton. For Newton, we only need to give it one thing, one number, double. I'm going to try, and let's call it xn. Okay. So, and what does xn need to be? Xn needs to be double xn 1 is equal to xn minus f of xn divided by f prime of xn. Okay, we need an f prime of xn. Let's go ahead and copy this sucker. So let's call it f prime. And f prime is going to be, f prime of x squared is going to be, what, 2x minus 5? There we go. So we want 2x minus 5. Get that count out of there. 2 times x minus 5, cool. And Sorry about that. And let's see what else we do. We haven't returned anything yet. And so that's our initial thing. So while, let's see, let's just do this too. Let's just do the while loop. I was going to copy, but then we'll probably mess up. All right, math, same thing. Dot absolute of f of xn1. So we're going to calculate this new x, and we want to calculate. We want to see if it's less than or greater than. While it's greater than the stop, we want to keep doing it. And down. We're going to want some Newton count plus plus. Let's go ahead and create that. Go ahead and create it. And count 0. Great. Let's go ahead and set Newton count to 0. Great. And now we can calculate. So we want our xn to be equal to, so we want our new xn to be the old xn, which is xn1, and then we want xn1 to be equal to, actually we want this again. Just take that, copy it, paste it. Is that not right now? Dot absolute value. It's like I don't, what did I do wrong with that? Need another parentheses. Okay, so fix that, I think. All right, let's see. That one goes with this one. This one goes with that one. This one goes with this one goes with that one. So I have an extra one. So what's wrong with that? Yep, that's a problem. All right, the reason why it said that it couldn't calculate for a Boolean was it had this whole thing in as an input for math.absolute value, and of course that's a Boolean. That's because I didn't have this parentheses. So I added that parentheses and we're good now, and we don't need this one. There we go. Now we're good. All right, so we're going to take f of x divided by f prime of x. It's cool. And we need one more parentheses. It's good. We haven't returned anything yet. And this is our while loop, which means we can now return xn1. Cool. And we're good to go. So let's take this, print it, and I'm going to show you, hopefully really briefly, how to do more than one in a kind of hacky way, how to do more than one. I make the Newton method. I'm going to call Newton. You don't need to give it two things. We only give it one thing. Let's give it, doesn't matter which number you choose. Let's give it A. And it has to be close though. And then Newton count. Let's run this sucker. Hopefully it's a lot more efficient than the other one. And it is, and we get -1. Actually, we get exactly -1, which is even better. And it only takes us 4 times. All right, so so now in the last video, I'm going to show you how to work it. So it's much easier to add multiple equations.